Hello everyone, this is Miss Chelsea and today we will be learning about molecule polarity. Our question of the day is to look at this Lewis structure. How will electronegativity affect electrons in this molecule? Our standard of the day is SC2B, which is to construct an argument by applying principles of inter- and intramolecular forces to identify substances based on chemical and physical properties. As a warm-up, I would like you to pause the video and consider how were the following groups made. If you have a partner, go ahead and discuss with them now. So when you have a molecular substance which has covalent bonds inside, the electrons are all shared throughout the molecule. Sometimes the sharing is equal, whereas others it is unequal. This distribution of electrons determines the molecule polarity. How can you determine the molecule's polarity? Well, first you need to draw the Lewis structure. Then draw a plus sign through the middle of the molecule. If the molecule is the same on the left and the right, as well as the same on the top and the bottom, then the molecule is symmetrical. If it is not the same, it is asymmetrical. If you look here, you will see that HCl is asymmetrical. Symmetrical molecules are always nonpolar, whereas asymmetrical are polar. You can remember this with SNAP. Polar molecules are molecules with unequal distribution of charge. For example, CH3Cl not the same on the left and the right, meaning that the area with the extra electrons or the higher electronegativity will hog all the negatives. That's why the chlorine ends up with a partial negative on the right, and the left side, which has hydrogen, ends up with the partial positive. On the other hand, a molecule with an equal distribution of charge, like CH4, is a nonpolar molecule. Remember, partial charges exist in molecules as well. The side with more non-bonded electrons is the partial negative. Go ahead, pause the video, and try the show what you know questions. So, let's look at an example, H2O. This has 2 hydrogens and 1 oxygen. Since hydrogen only has 1 valence electron and oxygen has 6, we will need to bond one of the oxygen electrons to each hydrogen. Therefore, we will have single bonds, HOH, with lone electrons left on the oxygen. This means that oxygen will have a partial negative charge, and the space between the hydrogens will be the partial positive. Since we have partial charges, we have poles, we have a polar covalent compound. Moving on to carbon tetrachloride, we have carbon with 4 valence electrons and chlorine, each with 7 valence electrons. So each chlorine can bond its one lone electron to a lone electron on the carbon, resulting in one carbon atom single bonded to each of the 4 chlorine atoms. Now each of these chlorine has 3 pairs of valence electrons that are unbonded. Since this molecule is symmetrical, it ends up being a nonpolar molecule. Now finally, we have Br2. Each bromine atom can only form one bond because it has 7 valence electrons. That means we have 2 bromine atoms single bonded together. Now notice how the electrons are evenly distributed between the 2 bromines. This is a symmetric molecule, so we have a non-polar covalent molecule. Now let's look at HCl. The Lewis structure should look like this. Notice how the electrons are concentrated around the chlorine. Well, that means we're going to have partial negative at chlorine and partial positive on the left side near hydrogen. And that means we have a polar covalent molecule. Now looking at C2H6, it should have a Lewis structure with carbons in the center surrounded by a bunch of hydrogens, and if you draw your plus, you should see that it is indeed symmetric on top to bottom as well as left to right. so horizontal as well as vertical planes. That means we have a nonpolar covalent molecule. Now, H2S is very similar to water, and so its electrons are concentrated around sulfur, giving that a partial negative charge up in the top left, and the bottom right is partial positive. Therefore, H2S is a polar covalent molecule. Number 7 is an oxygen molecule, which looks like this. Remember to make sure you double bond the oxygen so that each of them have a full valence shell. And once you do that, your molecule is symmetric in both the horizontal and vertical planes, meaning you have a nonpolar molecule. Looking at NH3, it will have a Lewis structure that looks like this. Notice how the nitrogen has extra electrons compared to the hydrogens? Well, that means that the top of our molecule will have a partial negative charge and the bottom will have a partial positive, meaning NH3 is in fact a polar covalent molecule. Next, let's look at carbon dioxide. That's one carbon and two oxygens. Remember, carbon can actually make 4 bonds, while oxygen can only make 2. Therefore, each oxygen will be double bonded to the central carbon. And once you do this, you actually have a straight line of a molecule. So it is symmetric, meaning it is a nonpolar covalent molecule. Next, consider PCl3. The Lewis structure looks like this. Notice how the chlorines are pretty evenly distributed. However, the phosphorus is got a lone pair of electrons. Well, that lone pair of electrons on top does not compare to the 3 pairs of electrons on chlorine. That's how we end up with a partial negative on the bottom and a partial positive on the top, leading us to a polar molecule. Now, for number 11, this is what carbon tetrachloride looks like. Notice how if you look at the carbon-chlorine bond, chlorine pulls a lot more on the electrons than carbon does. So the individual bonds are polar. However, the overall structure is nonpolar because the polar bonds cancel each other out due to the molecule being symmetrical. Another example of a nonpolar molecule with polar bonds is CO2 because the oxygen attracts the electrons more than the carbon does, making that a polar bond. However, because the two oxygens are pulling the electrons in opposite directions from the carbon, the molecule itself is nonpolar.